In this video, we're going to solve trigonometric equations using double angle identities. So in the first example, we have cosine 2 theta equaling cosine theta. And the issue here is that we've got two cosine functions with different periods. We have this multiplier of 2 making everything happen twice as fast as it does for this function. There's no technique to apply to this. We can't factor it to get it into a zero product property form. So what we want to do is take one of the double angle identities for cosine and rewrite this equation and see if it puts it in a useful form for us. I'm going to argue that the first two identities, because they have a sine function in it that doesn't look like it can be substituted in such a way to allow factoring to happen, aren't the best choices to try to begin with. But this one, if we make this substitution, 2 cosine squared theta minus 1, we'll have an equation that has only the cosine function in it. And that looks like it's going to have a quadratic form. And if it has a quadratic form, then we have tools for solving it. So I have a quadratic form here. This is a 2x squared form, minus 1 equals x. So because it's a quadratic form, I'm going to get it equal to 0 and try to factor the left-hand side, so I can use the zero product property. So I'm going to rewrite my 2 cosine squared theta. I'm going to subtract cosine right here from both sides, which is going to give me minus cosine theta, and I still have my minus 1. And then because it's a quadratic form, we're going to see if we can factor it instead of having to use the quadratic formula or completing the square. If it factors, we're going to get a 2 cosine here. Or if it factors easily, it's going to factor regardless, but it might not factor easily. So we'll get a cosine theta and a 2 cosine theta, because 2 cosine theta times cosine theta is 2 cosine theta squared. And we need a minus 1 in the middle, so I'm going to try a minus 1 and a plus 1, because 1 times negative 1 is negative 1, and 2 cosines times minus 1 is minus 2 cosines, plus 1 times cosine gives us minus 2 plus 1 is minus the cosine of theta, so that looks good. And then once we get this, we want to recognize that we have the zero product property. I have an a times b equaling 0, so we'll take and say either 2 times the cosine of theta plus 1 needs to equal 0, or the cosine of theta minus 1 needs to equal 0. So solving this one, we just need to isolate the cosine. So we're going to subtract 1 from both sides, and then divide both sides by 2 to get the cosine by itself. Then to get the theta out of the cosine function, we take the inverse cosine of both sides. So we're going to get theta equals the cosine inverse of negative 1/2. We want all solutions, so this is an angle. We want all angles coterminal with it, so plus 2 pi k. And then because of the even symmetry of the cosine function, we get a plus or minus here. We get two angles that work. And then the next step is to look at this negative 1/2 and say, can I simplify this expression or this angle? Is the negative 1/2 corresponding to a special angle? So we think about the unit circle, and we know that the cosine inverse is defined only on the interval from 0 to pi. So on this interval, where do we get an angle of negative 1/2? Well, that happens at the angle 2 pi over 3 radians, where we have the ordered pair negative 1/2 comma square root of 3 over 2. So I'm going to replace the cosine inverse of negative 1/2 with the angle I know it is. It's 2 pi over 3, and this is plus 2 pi k. Notice if we took the negative 2 pi over 3 and added 2 pi to it, we would get the angle down here in quadrant 3. We would get this angle reflected into this position, and we would get this guy right here. So the other one, we want to solve this other guy. I'm going to rewrite him. Cosine, we have cosine theta minus 1 equals 0, so we're going to add 1 to both sides. So we get cosine theta equals 1. We take the inverse cosine of both sides. We get plus or minus if we're being mechanical. We don't need it in this case. This is a special case angle, but it's still going to be plus 2 pi k to get all special, all coterminal angles. And then the cosine is 1 right here. At this point, 1 comma 0, the x-coordinate is 1. So this is a 0-degree angle, so we're going to get plus or minus 0 plus 2 pi k, which is just 2 pi k. So theta equals 2 pi k. So putting it all together, the solutions are theta is equal to plus or minus 2 pi over 3 plus 2 pi k, or 2 pi k, where we recognize that k can be any integer we choose. If we're asked to find the answers on a specific interval, we just pick the appropriate values of k. So here's another example that's going to involve a double angle identity. So we have the equation for sine theta cosine theta equals the square root of 3. And what we want to recognize is that this can be rewritten as 2 times 2 sine theta cosine theta equals the square root of 3. And then this is the double angle formula, identity, for sine of 2 theta. So we can replace this piece here with the sine of 2 theta. So we get 2 times the sine of twice theta equals the square root of 3. And then we divide both sides by 2 to isolate the sine of twice theta. Now we can take the sine inverse of both sides, which will break the 2 theta out of the parentheses. So we get sine inverse of the square root of 3 over 2. Plus, we want all angles that are coterminal with this one, because all angles coterminal with this angle yield a side ratio of root 3 over 2. So we're going to add plus 2 pi k. And at the same time, we're going to recognize that not only is this angle a solution, but the supplement of this angle is a solution. So what angle plus this angle adds up to 180 degrees or pi radians? Well, to figure that out, we'd say, hey, 2 theta has to equal, if we take pi minus this angle, we'll get the supplementary angle, or 180 degrees minus this angle will give us the supplementary angle. So we go pi radians minus the angle that is the sine inverse of the square root of 3 over 2. And we want all angles coterminal with this one, so we add plus 2 pi k. And then we want to step over to the unit circle and say, does this correspond to a special angle? If it does, we simplify this angle. If it doesn't, we just leave it like this in its sine inverse form. On the unit circle, we only pay attention, because we're working with the sine inverse function, we only pay attention to quadrants 4 and 1, because the sine inverse is defined on the interval, or over the angle interval from negative pi over 2 to pi over 2 radians. And where on that interval do I have an angle that gives me a side ratio of root 3 over 2? That's going to happen at pi over 3 radians, because on the unit circle, that is the place that has a y-coordinate of root 3 over 2. And the sine is the y-coordinate on the unit circle. So we're going to go twice theta equals this angle actually is the special angle pi over 3, and we are plus 2 pi k, and then we're going to multiply both sides by a half, and this is going to give us theta equals a half times pi over 3 is pi over 6, and a half times 2 pi k is going to be just pi times k. So here's one of the two solutions. And then the other one's going to be 2 theta equals pi minus, what is this angle? Well, we just calculated this angle to be pi over 3. The angle whose side ratio is root 3 over 2 is the angle pi over 3, so we make a substitution, plus 2 pi k. We get a common denominator, so we can combine these two, so we get twice theta is 3 pi over 3 minus pi over 3 is 2 pi over 3. And we could even notice that if we continue our unit circle around, 2 pi over 3 is going to be this angle right here that you get when you reflect this point over into quadrant 2, where the x-coordinate is now negative, but the y-coordinate is still positive root 3 over 2. So we could have found this just by looking at the unit circle because it is a special angle. But again, I like to do it this way. I think it's when it's not a special angle, this is the way that you need to do it most efficiently. So we get 1/2 times both sides. 1/2 of 2 theta is theta. 1/2 of 2 pi over 3 is 2 pi over 6. Plus 1/2 of 2 pi k is just pi k. And then we put these two together to get our final solution. Theta is the angle given by either pi over 6 plus pi k or 2 pi over 6, which actually should simplify to pi over 3, right? So I should simplify that. I did a half. The half is going to cancel this 2 here and give me a pi over 3. So we should write it simplified, and it's going to be plus pi k. And we want to make sure the reader knows that k needs to be any integer you choose. 0 plus or minus 1 plus or minus 2, and so on and so forth.